Alright, my dear students over there, I welcome you once again. This is your teacher, and your teacher is called Teacher Hakim. This is revisionug.com, the e-learning platform that provides education in its simplest through using video tutorials, and we are offering organized notes, easy to read and to understand, quizzes and examinable tests. Please follow us using the links below. Let us get started. This is our lesson number 2 under mole concept, and in today's lesson we are going to look at the empirical formula. We are going to look at the empirical formula. Yes, we are looking at empirical formula. So let us understand what an empirical formula means. It is the simplest formula, very simple formula that shows the simplest ratio. We are comparing the number of atoms of different the number of different atoms in a compound. For example, if I have my compound water, there meaning that the empirical formula is a skeleton of water. How will water look like? If I want to write the formula for water, how will that formula be? Meaning that it will be with hydrogen, it will be with oxygen, and hydrogen will be in 2 to 1. That is the ratio. So that is the empirical formula. Then the molecular formula, it confirms the real formula. Yes, it is this real formula. There are 2 atoms of hydrogen and 1 atom of oxygen, but empirical formula is just a sketch. Then the molecular formula, it is the accurate diagram, confirms that yes, this is the real formula. These are the atoms that must be there in the respective numbers. Okay, now let us get started, my dear learner. Don't forget to subscribe, like, share and follow. Okay, now how do we do this? Here they are telling us that a substance contains 17.7% hydrogen and 82.3% nitrogen by mass. Find the empirical formula of the substance X. Now when we are dealing with this, there are simple steps we are going to follow. 1, we start by identifying the elements there, and please be organized. You identify the elements. Now one of the elements, we have hydrogen. There is hydrogen, we write just the symbol, and also we have nitrogen, the symbol. Then after there, we have to write their masses. The masses given, sometimes they can give us mass in terms of percentages, sometimes they can give us mass in terms of masses, grams, but here there are percentages. Now this one, it is 17.7. now this one takes 82.3. Then after that, we need to write their atomic masses, also relative atomic mass of those atoms Z, because we are dealing with the atom Z, and hydrogen takes 1, nitrogen takes 14. Very simple, we put it there. Then after there, we are going to get what we call the moles. We are going to get what we call the moles, the unit of measurement. Now how do you get a moles? We get a moles, we get this percentage, this mass divided by the atomic mass. We get a mass and we divide it by atomic mass. Therefore 17.7 divided by 1 and 82.3 divided by 14. Therefore 17.1, this is automatic, it is giving us 17.77. then let us get our 82.3. We divide it by 14. What do we get? We get 5.88. now after there, we need to get what we call molar ratio. We compare now. Molar ratio, we get the smallest and we divide it throughout. Now the smallest is this one, 5.88, then 5.88. I'm repeating that. When you are getting molar ratio, you get the smallest and you divide it throughout. Now this one, the smallest moles, now these ones have been the smallest, then they divide it out. Then when divide, this one gives us a 1, and now let us divide this as 17.7 divided by 5.88. What do we get? We are getting 3.000, so we get a 3. Therefore, our empirical formula is going to be H is 3 and N is 1. Then let us arrange our thing: nitrogen first, then hydrogen last, and 3, and here 1. So our empirical formula is NH3. Do you know this? This is ammonia. So we have developed ammonia formula. That is very simple. Let us get another example. This is Revision UG. We provide education in its simplest form. Please embrace it. Just use your critical thinking. Be confident. Feel relaxed. Don't be stressed. Use the 3 C's: critical thinking, creativity, and confidence. Let us go and see number 2. Number 2 tells us a compound contains 1.44 grams of X and 0.96 grams of oxygen. Calculate the simplest formula of X. That is compound. That is our compound. What? Our compound. It contains X and oxygen. Now let us identify our elements. Still very simple elements here. Now we have element X and element oxygen, which is O atom. Now let us write their masses that are given. Now the mass for X, they are saying it is 1.44, right? And oxygen is 0.96, right? Don't stress. Then you write the relative atomic mass RAM. That is, for X is 24 and for oxygen is 16. We need to guess the formula when those things combine, which formula are they going to give us. Now from there we write there moles, right? We get the moles. And how do you get the moles? We get the this mass divided by relative atomic mass. That is 1.44 divided by 24. What is up divided by what is down? Simple. 0.96 divided by 16. Now let us compute this. This is 1.44 divided by 24. What are we getting? 0.06. Then here what are we having? Let me clear this one. This is 0.96 divided by 1.6. What are we having? 0.06. Then after there we are getting our molar ratio. Few steps, my dear student. Now molar ratio, we said we get the smallest, divide it throughout, but now all of them they're the same, so we divide throughout because they are equal. 0.06, 0.06, 0.06, then 0.06 to 1, 0.06 to 1. Therefore our empirical formula is X1O1, which is the XO. This is our formula. That is finished. The simplest ratio is 1 to 1. Alright, and if you can try to guess, if I can try to guess, this is magnesium. Now this is magnesium. Now this X is magnesium and this is oxygen. When magnesium combines with oxygen, what's that? Magnesium oxide. Really? Right. RevisionUG.com for us. Okay, now let us get another example here. This other example, let us get this other example. let us get this other example 3. Oh, what is this example having for us? It says a compound Y contains 1.5 contains 15.8% aluminium, 56.2% oxygen, 28% sulfur. Onule? Yes. Catch the empirical formula. Oh, let us get started. This is our food to eat. We start by identifying the elements. Now, what are the elements we are having? One, we have aluminium, which is Al. Then there is sulfur, which is S. Then there is oxygen, which is O. Then after that, let us write their masses, percentage composition by mass. Then aluminium takes 15.80%. Then oxygen takes 20. No, really? Oxygen takes oxygen. No, this is sulfur. Sulfur is taking 28%, and aluminium. Yes, oxygen takes 56. Yes, 56.2. Then after there, we write their relative atomic masses, right? For aluminium is 27, for sulfur is 32, for oxygen is 16. What next is to get the moles. How do you get the moles? The upper one divided by the lower one. Now 15.8 divided by 27. Let us divide that and get the answer there, and then this is in 15.8 divide it by 27. What do we get? We are getting 0.585. That is done. Now let us come to the column for sulfur. Column for sulfur, this is 28 divided by 32. So 28 divided by the 32. What do we get? We get 0.875. Now let us come for oxygen. 56.2 divided by 16. What do we get? This is 56.2 divided by 16. This one is giving us 3.51. 3.512. Now let us get the smallest. Oh, my calculator. First come back, calculator. Now we need to get the smallest, and the smallest of all is 0.58. So we divide that. This is now the mole ratio. We are getting mole ratio divided by the simplest 0.585 divided by 0.585 divided by 0.585. Now this is going to be a 1. Now let us divide this one. 0.875 divided by 0.585. The answer is 1.49. That is 1.49. Then this one is going to give us 3.5. Let me this is 3.512 divided by 0.585 is giving us 6. This one is giving us 6.00, so we take 6. Now when you look at this number, my dear learner, if you get this number like this, don't round off to make it as 1. No, here we are going to use what we call vapor density. We are going to multiply by 2 until we get a number, until we get a whole number. Okay, the simple trick is to remember, whenever you get a number which is nearer to 5, 6, 7, 8, 9, Now what you do, you multiply that number by 2 until you get a whole number. So this is what we are going to do. Multiply by 2 here, we multiply by 2, we multiply by a 2. So this is going to be a 2. Now 1.49 1.4 times a 2 is giving us 2.98, meaning that now when you look at this number here, 2.98, it is giving us 2.98. Now when you round off to this one, it's going to be 2. Now this is a 0, because this one you can round it off. But now when you have 1.49, then when you round off this, is going to be 1.5. Then when it's 1.5, this is you cannot still again round off to this. What you do to this one, don't round off, you just multiply this one by a 2, then this is a 3 still. So here it's giving us 2.98. If you round off, we get 3. Or if you had 1.49, you round off to this one, then 1.5, then multiply by 2 here to the first decimal place here, then that's when you multiply by 2. But that second one, you can round off. When you see this one is giving you this, then you bring in the multiplication. So this one is a 3 and this is a 12. Therefore our simplest ratio is going to be 2 to 3 to 12, and the empirical formula is going to be L2 S3 or 12. Or we can condense this formula to be aluminium, which is 2, then in bracket SO4, and we put a 3 there. Hey, do you know? Because if you multiply this by this one, you are getting 12. Then this by this, you are getting this one. This is aluminium sulfate, and this is also the same. If you open this bracket, you are coming back here. So this is aluminium. So in this question, what we've learned, and a new thing we have learned, is that when you have that number, which is 1.5, 1.6, 1.7, like that one, multiply by a 2. Just that one. Okay, that is very simple. Let us continue from the first question. Let us now look at this second question, question number 2. This question number 2, we are going to see how to deal with the molecular formula. The molecular formula, as I told you, it is the formula that confirms the real ratio of the atoms that must be there in a given compound. So from our first question, we've seen that our first compound has been aluminium sulfate. Then we want to confirm, are they 2 aluminium atoms, 3 sulfur atoms, and 12 oxygen atoms? Right, let us get started. So how do we do this one? We just get the empirical formula, we let it, or we multiply it by any given number of atoms. So for example, let us take this one. That was aluminium. Oh, the thickness is too big. It is too thick. Let us reduce. Sorry. We reduce the thickness. Alright, so it has been aluminium 2, then S3, then O12, and then this has been our empirical formula. Then we let this empirical formula and we multiply it by any given number of atoms. Let the number of atoms be maybe X, N, Y, Na, so by N, then this is going to be providing or producing the mass of 342 grams. And then we are now going to look at the mass of each atom. Then we are starting with aluminium. Then remember, we said aluminium, these atomic masses of different atoms is given, so you don't need to cram them. So but aluminium, it is 27, but there are 12 of them. As you can see, there are 2 atoms, then each one taking 22, and then we have plus, then sulfur, then there are 3 sulfurs and each sulfur is carrying 32. Then oxygen, there are oxygens, there are 12 of them, and each oxygen is carrying 16. Then all of this one in the given number of atoms, then is giving us 342 grams. Then this 22 by this one, we are getting 27 by that is 40. This is 4, then 54, right? That is 54. Let me get the calculator here. Then the next one there, it is as you are calculating, this is 32 by 3. So by 3, this one's giving us 96. Then plus 12 by 16. Yes, this is giving us 192, but all of this one into n there. So the first one was 27 times 2, which was 54, right? Now, so we are going to add, that is 54, then plus the 96, then plus 192. This is giving us 342 into our n. This is equal to also here 342, then 342 42 here. Then this is going to be 342 n is equal to 342. Then we divide by 342 in order to get a value of n, 342 to get a value of n. So our n here is equivalent to a 1. So after doing that one, getting the number which must be multiplied to get 342 is 1. Then we bring our empirical formula, which is aluminium 2, sulfur 3, oxygen 12, into brackets 1. So if we open the brackets, so it's going to be aluminium 2S3O12, or aluminium 2 open brackets sulfate, like this one. So this one becomes the molecular formula, the confirmed formula. In aluminium sulfate, there are 2 aluminium atoms, 3 sulfur atoms, and 12 oxygen atoms. Therefore, let us now move on and see another example. Okay, so this example says, it involves combustion. You remember, when we talk about combustion, we have 2 types of combustion. There is complete and incomplete. Whenever you're talking about combustion, we are seeing burning, and that is oxygen. Automatically, when we talk about combustion, that is oxygen, because it is the gas that majorly supports burning. So the complete combustion of 7.5 grams of an organic compound. So we have an organic compound, but this organic compound, it was 7.5 grams. Then let us call that compound Q. Right, it's called Q. So our organic compound Q weighs 7.5 grams. Then it went under combustion. Then hydrogen and oxygen gave carbon containing Q containing carbon, hydrogen, and containing carbon, hydrogen, and oxygen gave 7.9. Let me check the question clearly here. 7.9, 17 grams, 7.9. So on burning, it produced certain compounds there. So it produced the complete combustion of 7.5 grams of an organic compound. I'm repeating, Q containing carbon, hydrogen, and oxygen. It gave 17.8 grams. Sorry, so this is an error. So this is 17.8 grams of carbon dioxide and 9.27 grams of water. calculate the simplest formula of Q. So we are going to calculate the simplest formula of what? Of Q. Remember, they have told us that our element, what are we going to start with? We are going to start with the identifying the compounds there, the elements in the compound. The elements in the compounds there. So the elements in the compounds, our compound, let us identify the elements there. One, there is carbon. They have told us carbon. There is hydrogen, and there is also oxygen, right? So let us now write their masses. So we need to get a mass for carbon, we need to get a mass for hydrogen and oxygen. But when they have given us the question, they have not given us the carbon, they have not given us hydrogen, nothing. They have told us carbon dioxide and water, meaning that from carbon dioxide we can get carbon, and from water we can get hydrogen. Then let us now first get carbon dioxide here. Now, are you seeing this carbon dioxide? It has its mass. What is its mass? That is its RFM. The relative formula mass. Then it has carbon, it has oxygen, 2 of them. Now carbon, it is 12, and oxygen, it is 2 times 16. Now this is 12 plus 32, which is going to be 44 grams. Are you seeing this? It means that we are going to use this one to identify the carbon which was there, because now we are seeing that 44 grams of carbon dioxide contain 12 grams of carbon. Are you getting that? Now from there we are going to get this and say 44 grams of carbon dioxide, they contain 12 grams of carbon. Then but here the carbon dioxide which was produced was 17 only 0.8. Then how much carbon was there? Now 17 grams, it is 17.8 grams of carbon dioxide which was produced. Now it will contain now 17.8 out of 14. Out of 44 times the what? The 12. Now inverted L, this one over this times that one. Now let us compute this one and get to see what we are having there. So calculator, where are you? Calculator is here. Okay, so what are we having? We are having 17.8. We divide it by 44. What is the answer? Then times 12, then we get 4.8. There we are getting 4.85. oh gosh, sorry. So automatically our carbon is 4.85. Now let us go and use water. Now let us write our water here. Then this water has hydrogen, and there are 2, and oxygen. Then hydrogen, this is 2, then plus 16, which is now giving us 18 grams, which means that 18 grams of water, it is producing, or it contains how many hydrogens? It is containing 2 hydrogens. Are you getting that? 2 grams of hydrogen. Then how much water was produced? Just 9.27 grams of water. Then how many are we going to produce? 9.27 out of 18 times that 2. What are we getting here? So that is, let me clear this one. So that is 9.27 divided by 18 is equal to, then times 2. What are we having? 1.03. So for hydrogen is 1.03. Now what is missing? What is missing is for oxygen. Now how are we going to get oxygen? Let me extend our oxygen just a little bit here. Now remember, they told us that the carbon, the organic compound which was bad to produce this oxygen, to produce this carbon dioxide, to produce this hydrogen, then it was weighing 7.5 grams. But now let us see the grams of carbon and hydrogen so far. So when we add 1.1, then 4.85, what I having, this is 8, this 5, 8, then a 5. So that two only occupy 5.85. Therefore, check that the other balance it's for oxygen. Now let us get a balance for oxygen. So from this one, which is 7.5, we take off 5.85. Now let me hope that we are still together. This is 7.5. Take away 5.85. What's the answer? It is 1.65. So oxygen is 1.65. That one is done. Then after that one, we take their relative atomic masses. This is 12, this is 1, and this is 16. Then we take their moles. Now that is 4.85 divided by 12. What is the answer there? Now this is 1.65 out of 16. Let me first take that one, divide by 16. This is giving us 0.10. Then this is going to be 1.03, because this is going to be 1.03 divided by 1. Then let us come to this one. This one is going to be 4.85 divided by 1, 2. So this is going to give us a 0.40. Yes, we can stop there. Now out of that one, we are going to choose, or we are going to get the smallest. So out of the three, we need to get which one the smallest. So which one is the smallest? That is 0.1. So we divide by throughout 0.01, throughout 0.01, throughout 0.01. This is going to be a 1. Then we divide this one. This is 0.40. We divide it by 0.10. So the answer, this one becomes a 4. Then let us come to this one. This one is giving us 1.03 divided by 0.10. This is a 10 point. Now this is 10.3. Now that number, we are not going to multiply it by 2, right? Simply because when do we multiply by 2? We multiply by 2 when the number is from a 5. When the number is from a 5, 6, 7, 9 there. But that one we just round off and we take a 10. Therefore, our simplest ratio is our simplest ratio here is 4 to a 10 to 1. And then the empirical formula, let me rub this one, and the empirical formula here is, let me rub this one, and the empirical formula here, it is C4H10 and oxygen. So my dear learner, you've been a good learner. So let's see whether we have any other example. No, we don't have any other example. So this is the task you have to do. Please, below the video, do the task. The notes are also there. We meet in the lesson 3. May God bless you. Remember, it's revisionug.com.